Hello friends, you can log on to primeaptacademy.com to access complete free video courses. So this is the 26th question of the algebra chapter. So question says, sum of roots of a quadratic equation is negative and product of roots of the same quadratic equation is positive. If both the roots of the equation are real, okay, then does one root raised to another root equals a real number? So first of all, both the roots are real. So one root plus other root. The sum is given to be negative and product is given to be positive. So sum is negative, product is positive. One root plus other root is negative, one root times other root is positive. This is only possible when both these roots are negative. So this one root that is negative, also this other root that is also negative. The question is asking that then does this one root over other root equals a real number? One root raised to power other root, sorry. So that means we have to figure out that whether this negative number raised to power negative number equals a real number. So it is possible that it can equal a real number, but is it always the case? Because when it says that one root raised to other root equals a real number, that means it has to satisfy this case all the time. If I take one of the root as, let's say, minus 1 and the other root as minus 1 by 2, it is a possibility. So over here it will become 1 upon square root of minus 1, which is not a real number. Okay, so if there is a case, let's say if I have one root as minus 1, the other root as minus 3, okay, so this is equal to minus 1, so this is coming out to be a real number. This negative raised to negative is coming out to be a negative real number, but here negative raised to negative is coming out to be 1 upon square root of minus 1, which is not a real number. So does this thing, one root raised to other root, always equals a real number? No, it is not equal to real number always. So if it is not always, you will have to answer this as no. Okay, so no over here is the right answer. Okay, that's how we solve this.